Hi folks, welcome. This is actually the Creating Dynamic Visualizations with Event Log Files session, and I will be your MC and host today. My name is Adam Torman. I'm a Director of Product Management at Salesforce.com. I am a certified Salesforce administrator and Force.com developer, and some of the code you will see today I wrote. You'll be able to see it pretty quickly. It's as ugly as my team keeps reminding me. And then you'll see some code that is much more elegant that one of our developers wrote, and you will get to see a very cool sneak peek at a product that is coming out from one of our partners, New Relic. Feel free to follow me at Twitter, at atorman, or my blog, salesforcehacker.com. Okay, who here has never seen the safe harbor statement before? You're in for a treat. We would like to ask that you please make all seared safe harbor certified salmon purchasing decisions based on existing flavors and textures and not based on future biogenetically engineered flavors. This is actually a friend of mine was on date night. He sent me this, and his wife got quite upset that he was texting me instead of being on date night. So the real safe harbor says, please make purchasing decisions based on existing functionality, and the cool thing about today is everything that we're going to show you, you can do today on a developer edition org. So what will we cover? Well, we're all about being Big Brother. We want to find out what our users are doing and what the code actually looks like that runs in production. We have great debugging tools, but we want to take this to the next level and see what's happening at runtime. And because we like to understand large scales of data, we're going to take a look at 300 million rows of data and take a look at what that looks like in various forms. And we'll figure out from this session how we access that data, how we orchestrate it, and how we build custom visualizations when normal visualization engines don't work for us. I'm very excited that we get to get a sneak peek into a very cool New Relic product that is launching called Insights. And it's a phenomenal platform for ingesting and working with this data. And we have someone from New Relic who's going to help us with that. And then lastly, we'll go over some best practices, tips, tricks, all of that. OK, so what is this? The feature is called application monitoring, but that's the marketing name. The actual object you'll encounter in the API is called event log files. Out of curiosity, let me see a show of hands of people who have worked with the Salesforce API. Raise your hands up high. All right, you're definitely in a good session for that. Now, what this object does is it allows us to track activity, adoption, audit behavior, and even find out about the performance of your custom code in a Salesforce organization. So why use it? Lots of reasons. First and foremost, it's because most of our customers come from an on-premise world and are used to being able to instrument using Log4j or other kinds of technologies, being able to use syslog, being able to pull down those logs and do something with it. And event log files basically makes it possible for us to open up our internal app logs. We do about a terabyte of log files per day at Salesforce.com, per pod. And every single night, we ship those logs off to a Hadoop server that map reduces over them and produces CSV file content that is blobbed into our content management store called Visualforce. And we create that content into orgs, so we now have multi-tenant log file data residing in people's orgs so that they can have access to the exact same kinds of data that Mark Benioff uses to run adoption metrics for his keynote, that our customer-centric engineering uses to troubleshoot cases. All right, some typical use cases. Performance, we want to know what's happening with our Visualforce page views. We want an APT, an average page time. We want to be able to prioritize, especially if we're in enterprise IT. Who out there is in IT or an admin of the org? Raise their hands up high. Right, prioritization is important. We need to understand the scope of what people are doing in our org. Or status, tell me what's happening with my batch Apex. All right, so how does this work? This is an API first feature. It's an API only feature. It means there is no UI. There's no place in setup that you click on where you go and you download this log data. It's accessible via the event log file S object, and it's always based on the previous day's log data. So it's not designed to be really real time. It's really designed for forensic analysis, for understanding trends over a period of time. We currently support 28 different types of events. I'll tell you more about that in a minute. We're launching a paid add-on SKU in November where we will retain up to 30 days of data for EE, that's Enterprise Edition, UE, that's Unlimited Edition, and PXE, which is Performance Edition orgs. But as of today, we actually enable it in everyone's Developer Edition org for free for 1-day data retention. Let me see a quick show of hands. Who out there has a Developer Edition org? All right. Who here knew that they had access to this data? All right, 2 people, nice. Did your homework, I like it. All right, so let's take a quick look and see how this works. Okay. First off, I'm in a Salesforce org, my demo org, and I'm looking at a Visualforce tab pointing to a very simple jQuery-based page that consumes our REST API. It's a RESTful API. And I'm going after version 31 of my API, and I'm passing in a SOCL query. Anyone know what SOCL stands for? Please. Excellent. Salesforce Object Query Language. The object we want is event log files. So I'm going to get the ID, the event type, the log date, the log file. Most importantly, I'm going to get this object, event log file. I'll submit it. I'll get back some JSON. For instance, there's my Apex executions. In fact, all of my Apex executions that happened just yesterday, and I can even measure the size of it. That way I can allocate space to download it. Now when I take a look at the data itself, I'm just going to paste that endpoint directly into my jQuery field. I get the first header field for my CSV, and then I get all the data after that. All right. It's not difficult to access this data. So what kinds of files do we support? Apex callouts, executions, SOAP, trigger, everything around the API, bulk API, REST API, metadata API. Visualforce, one of the questions we oftentimes hear, or I hear, is I just want to understand how long is the longest Visualforce page, and on average, how long is it taking for Visualforce pages to load? Because I might have to have a conversation with my developer to fix that. How do we download this? Well, the reason we built this API first is because we wanted an integration strategy. We wanted to make it easy to get data from Salesforce into a back-end reporting system or into a partner like New Relic. So I'll give you an example of an automation script that we wrote to do this. I'm going to go over to Bash. I kind of date myself. I used to implement CTI, and we used Bash and Shell all the time. And all this is going to do is going to use curl and our REST API and OAuth to authenticate in and pull down data. And now we're looking at a stream of data. This is all data from yesterday in my demo org. And what this happens here is this downloads then into a series of files. So for instance, there's Apex execution. Or maybe I want Visualforce. And I can open that up into Excel because it's just a CSV. And now I can see all of my URIs, where it happened, how long it took, and what user actually interacted with that page. All right. That's the basics behind the feature and what it's about. Now the question, do we build or do we buy? So I've spent a lot of time here at this Dreamforce showing Salesforce Analytics and the things you can do with that to be able to visualize this data. It's a very powerful platform. But this is really an opportunity to talk more about how we integrate with other platforms and other systems. So another way you can do this is through an Isv Visualization Engine. For instance, Cloud Built, which is down in the CloudForce Expo downstairs, has a very cool app called Easy Cloud Audit for adoption. Fair warning, also in the Expo area, is all about healthcare. CloudLock is all about transaction security and giving you geolocation where people are downloading reports. Splunk gives you an enterprise view. But I'm really excited today to show you, or actually I won't show you, I'm going to have Heiko come up and show you a really cool integration that New Relic's built using their Insights tool. Out of curiosity, who out there is using or knows about New Relic? Raise your hands up high.
Wow.
All right, you're in for a treat. Heiko,
thanks,
please
Adam.
Welcome.
All right, wanted to start off for those of us who, whoops, this is not the slide that I was expecting. Do you have my slides?
I do not, so this might be...
Okay, I got to improvise then. Do you have New Relic open in the background?
in Firefox, last tab.
Okay. All right, so for those of us who don't know New Relic, we grew up as an APM company, Application Performance Management. We're founded about 6 years ago by Lou Cerny, and New Relic is his second go-around in the APM space. Sold his first company to CA and decided there's something that we need to do better about APM. So out of that resulted New Relic, and we recently moved into a space called software analytics, and that's what Insights actually caters to. Insights, think about it as of a massively scalable real-time event database. And when I say real-time, what that means is you can query it in real time. It's super fast. What we've done at New Relic is we've taken the event log files, we've built some Apex code, and that Apex code actually imports event log files from Salesforce into New Relic so that you can do more with it. There's a ton of use cases. We're looking at a dashboard here geared towards a Salesforce admin that tells us how fast our Apex code is performing through the course of the day. One thing that I notice is there's certainly times during the day where Apex code performs faster, and there are times where it's not that fast. Might be useful to schedule your batch jobs. Where are API calls coming from? Adam mentioned adoption trends, like which functionality that we've built for our Salesforce users is actually being used and how often. And we might deduct initiatives from that where we see mobile isn't being used. How do we drive our users to use Salesforce One more often? Use case that Adam mentioned earlier, what are our worst performing Visualforce pages? Now, there's two types here. One is by maximum runtime, and one other one is by average runtime. What can we do with this data? Well, if we take this one, it might be nice to know who the users are that had that, that had that bad user experience. User full name, and then we hit enter. Oh, Adam Atman was the one that had the worst experience. So you get the idea. We can now reach out proactively to that user and maybe offer a fix or have them do it again. One quick thing, I'll be available for questions after. We have some flyers, so come see me after the session. Thank you, Adam.
Heiko, thank you. It's interesting, when Heiko first showed me this, one of the things that kind of blew me away was it was remarkably easy to get the data into Insights. And then from there, it was very easy, as we started playing with the NRQL language, to be able to do things like joins and be able to take this very scalable data. Right? It became a great analysis platform for me without having to write a single line of code. I just had to understand NRQL. All right. So then we get into the question, oh, and by the way, if you're interested also, Heiko will be up for questions, but there's also a link up there, newrelic.com/Salesforce, to check out more about this integration. All right, so then the question comes, well, if you're not looking to buy a solution, you really want to be able to start to build, maybe because you have a custom workflow, or custom integration, or a very different kind of use case that goes beyond just analysis. You're going to have to start to look at different platforms, like Force.com or Google Charting API. Who out there is coded with Google Charting API? Raise your hands up high. 1 to 2 people. All right. I like it. It's very nice. It's well documented. How about D3? Anyone code on D3? Oh, you all are brave souls. All right. We're going to take a look at an example of each of these 3 different platforms and why we would want to build visualizations on them in the first place. And the first one is a very simple visualization so that we can start to understand the schema and, more importantly, understand how we can parse some of this JSON or parse some of this CSV and make it more intelligent. So here's my use case. I want to easily understand my data schema and flow so that I can build and model my visualizations. So let's take a look at a quick app. Out of curiosity, who's built code on force.com before? All right, most people. Excellent. So the first thing to know is we use Visualforce as a UI layer and now Aura. The underlying logic is stored in Apex. And all we're doing here is taking Apex and deserializing base64 content so that we can actually view it within our UI. So in my case, my workflow was very simple. I want to be able to at least visualize these files. For instance, I might want to see my Apex execution that happened yesterday. And I don't want to have to go through the process of downloading my files and opening Excel. I just want to be able to browse this. So I might click Apex execution and go. And this brings back that file data. I can see things like the timestamp and GMT. And notice that timestamp, kind of interestingly enough, it's like epic time. A lot of systems do not like that. So we'll talk about how we convert that. Request ID, which is useful for correlations. You'll see a lot of by reference ID, which is kind of interesting because a lot of my questions revolve around answering who did what. So I don't want to know that 0053, lots of zeros, 96CRF did something. I want to know, whoops, when I get an exception. That's no good. Try that again. Try that with URI. All right. And an exception. OK. Best laid plans of mice and men. Really, truly. It is possible to pull out from the API and convert it into an actual named field. One of the interesting things here is part of the data set that we really like is that fact it gives us numbers such as runtime, so I can see how long it took for a page to load. And I can have an IP to understand where the actual activity took place. All right, a couple things about this code. First thing is, right now, I want to create that pick list so that it gave me the ability to have my log date and that event type in the pick list. But most importantly, if I picked something, it needed to have an ID so that I could make a second query to pull back that log data. The next thing is, this is a blob data type. It's base64, which means the first thing I need to do is get back that blob, and then I need to deserialize it. So here we go ahead and we get the blob, and we pull back the actual information that was selected from that ID in the pick list. All right. Now things get to be a little bit more interesting because in Apex, we then need to parse the CSV and make sense of it. So you have here the CSV. All I'm doing is parsing it and putting it to a string. So I convert the blob to a string, parse out the CSV, and then that conversion function, had it worked properly, would have basically said, based on the key prefix, in this case 005, which is a user, go ahead and do a separate lookup on user and pull that information down and convert it over to the actual username rather than look at an ID. So just a couple lines of code. And then lastly, this huge monster of code is really doing nothing more than taking that CSV and generating as a string and making sense of it so that we can actually look at it on the screen. All right, all of this you can find under bit.ly parse CSV with Apex. It's actually in Visualforce. All right. So that's cool if you want to do some very simple, low-volume-based visualizations and just understand the schema. What about Google? Google Charting API came out a couple years back, and very well supported, very well documented by Google, helps start to take some of the CSV data and create some custom visualizations for interactivity. And this would be a reason why you would actually want to build a visualization around this data. It's because an analysis tool is great, but we want to have a workflow that goes a step further. So here's my use case. I want to track how long it takes for my Visualforce pages to render in production. so that I can easily create a follow-up task for a developer to refactor the most challenging pages. Right? I can either run a report and share that report with my developer, or if I'm using Salesforce and using tasks in Salesforce, I might want to create a follow-up task so that they can follow up and fix that page. First thing to understand is the data set. Within the Visualforce file, I'll see runtime, and I can roll that up by the URI or page name. Either one, they're actually the same attribute. And what that buys us is the ability to actually create bar graphs that I can interact with. So let me give you an example of this. Right now we're looking at a Visualforce page. There is an Apex controller behind this that's doing some of the heavy lifting for creating tasks. But the actual rendering of the chart itself is all Google Charting API. And the first thing is, all of these values are already been pre-aggregated and rolled up. So I might have a question about this one right here, the SF aggregation job runner. Seems like it's taking a long time on average to run. What's nice about Google API is that I can click on it and it actually can do something with that value. So I can pass that value out. I selected a value of 44,380. I can fill in a form field, submit that, call an Apex remote function that creates a task. And when I look at my task list at the bottom, there's now a task that we created automatically to fix that Visualforce page based on that render time. Right? So this is more of an interactivity level that we want from the visualization. Let's take a look at how this was done. First thing is, most of this lived in the Visualforce page. We'll set some form submission information based on our inner HTML value, which is what was actually selected. And we'll add in a message that just simply says, fix your Visualforce page, the render time in milliseconds is whatever was selected. The way Google Charting API works is you add a listener so that when that selection happens, we can pass out that message. All right, so then we show that selected chart value, and we submit that message off to jQuery, which handles the heavy lifting for the form field. In jQuery, you have to call, you don't have to, but it really helps. jQuery.noConflict kind of clears things out. And then we have a function that we're going to call into Apex using Apex remoting that's going to pass out that subject that you saw in the box so that we can create a task. And then lastly, the JavaScript remoting will actually go ahead and create a new task, passing in that subject, inserts the task, and returns back the task ID. All right, a simple example of just basic interactivity. The last demonstration we want to show you here is really where we start to get into more animated visualizations, where we want to be able to have something that has a lot more interactivity and a lot more custom things happen so that we can have a discussion around what's happening. And our particular use case here is around prioritization. Who here has ever had a prioritization around the projects that they should take on? Some people, maybe, right? What are some of the things that come up? Who's using this? How often are they using it? How old is it? Do we really need to change it if it's not broken? You know, it's interesting. I came to Salesforce 9 years ago, and we are now in version 32 of our API. When I joined, we were about version 15, 16, I think. But what's incredible to me is, in some places, some of our customers are still using all the way back to version 3 of our API. And they still have applications running because we have backwards compatibility with our API. We'll ensure that will run pretty much forever, or close to it. And so I want to understand what some of those older API versions are doing so that I can have a conversation around whether or not I should maybe clean up some of those versions. Maybe I should upgrade them. And for that, we built a D3. Actually, Thomas built a D3 visualization to give us some idea of how this works. So the first thing to understand as you watch all these bubbles pop around is this is 9 months worth of data. And this is 9 months worth of data across 32 versions of our API. That's basically 300 million rows that represent on a daily basis what's going on with each version of that API. What you see in the y-axis is the average number of rows processed. So each time that API version is invoked, it might bring back 1 row, it might bring back 100,000 rows. The more rows it brings back, the more critical it is to our application infrastructure. And then on the x-axis is the count of API calls. It's the number of times each day we actually are calling that API version. Everything's been pre-aggregated just to make this make a little bit more sense. Now, I really want to have a conversation around some of the older API versions. So we might toggle this down to just say versions 3 through 10. And notice as we move the toggle here, I'm just looking at those specific API versions. And I can see, for instance, in this case, version 3.0 is still being used. And while we have a good number of transactions here, over 100, we're returning back almost no rows. And in fact, watch that 3.0. It stays down there at the very bottom of the y-axis. And that tells me that something is using it a lot, but it's really not doing its job. So it's probably pretty safe for us to upgrade. And it's probably something that we should get rid of anyway, because it's really not doing anything with any rows of data. Maybe it's just doing describes, I don't know. But it changes the conversation, because now I can talk with my developers and my integration specialists about upgrading. By the way, has anyone out there watched TED? TED Talks? The Hans Rosling Wealth of Nations visualization? That's exactly what this is based on. Being able to take a large scale of data and map it out over time. All right. So to explain how this visualization actually works at a code level, I'm going to have Thomas Da Silva come up from our team, and he'll tell you a little bit more about how we did this.
Hi, I'm Thomas Da Silva. I'm a dev on the platform monitoring team, the team that built event log files. And I'll be going over some of the code we used to generate the visualization that Adam just talked about. So the data that we use for the visualization consists of 9 months of event log files, specifically the API event log file, and that represents around 300 million API events. So this is too much data to visualize on a single chart. So what we need to do is reduce the data. In order to do that, we calculate the average of rows processed and the count of API events, and we group them by day and API version. And if we do that, we reduce it down to 7,000 rows. So once we do that, we generate a JSON file, and we use that file for the actual visualization. So this is the original event log file data. So it's a CSV file, and it has a bunch of columns. Each column represents an API attribute, API event attribute. Each row is one API call. And we're only interested in 3 out of all the 3 columns out of all of these columns: the timestamp, the API version, and the rows processed. So this is the actual JSON that we generate. So the JSON is just an array, and each element in the array is a dictionary. And there are 3 key values in the dictionary. The first is the API version, and the second is the average rows processed and the count of API calls. So these 2 are themselves arrays, and each element in the array consists of 2 values. One is the timestamp in just Unix epoch time, and the second value is just the actual value, either the average rows processed or the count. So this is the part of the Python script that I used to convert event log files to the JSON data. I chose Python, but you can choose any scripting language or programming language of your choice. So what this does is, so it takes as input a directory that contains event log files. It processes the files one at a time. It loops over each file in the directory. And so what this function returns is a map from API version to an array, and each element in the array contains a timestamp and the count of rows processed and the average number of rows and the total number of rows processed. So here all I'm doing is I'm looping over every file in the directory. I'm sorting the files by file name, and I'm only processing CSV files. Here I assume that the file name has the log date, so I I use this regular expression to extract the timestamp from the file name. Then I process the file one line at a time, and here I only extract the columns that I'm interested in, so API version and rows processed. So I use these two values to build a map for this particular file from API version to count of API events and total number of rows processed. So once it processes all the lines in the file, at the end, I use this information to actually add a value to the map that I'm returning from this function. So that happens at the end here. So this map is basically API version to an array, and the array has three values: the timestamp, the count of API events, and the total number of rows processed. So once I return this map, I have a second function. So this just generates the JSON data actually, and it uses the map that the previous function generated. So here, all I'm doing is, again, I'm just looping over the map that the previous function generated, and I'm looping over all API versions. Then I take the array, and I loop over every element in the array. So there are three elements in the array. The first is timestamp. The second is the count of API events. The third is the total number of API events, and we need to convert that to average. So we take the total and divide by count to get the average. So once I have these three values, that's what I need in the JSON data structure, and I create the JSON data structure, and I just write it to a file. So the other thing that this function does is that it gives you the min and max values of the count and average rows processed, because we need that to set the scale of the chart that we are for the D3 visualization. So next, here's the actual D3 JavaScript that we use to generate the chart. So the first three functions are just accessor functions that specify what dimensions of data we are visualizing. So on the D3 chart, the position of the dot on the x-axis represents the count of API events. The position of the dot on the y-axis represents the average rows processed, and the color of the dot represents the API version. So the next three lines, I'm just setting up the scale. So here, for the x-axis and the y-axis, I use a log scale because the value of the data for count and rows process varies a lot between small values and large values, and it's easier to visualize this if you use log scale. So here I set the range of the domain based on the minimum and maximum the value that I got from the previous function, the Python function. And then here I scale the range so that the values fit between the height and width of the chart of the actual D3 chart. The third thing is just a color scale. So here it's just a simple linear scale. So our APIs vary between 3 to 32. So I say everything between 3 to 15 should vary between red to white, and everything between 15 to 32 should vary between white to green. Then I just set the start date and end date. So this is just epoch time of the earliest and latest log date of our event log files. Next, I just load the API data, and then I draw one dot per API version. And I also add a label at the center of the dot, which is just the API version number. And I initialize this to the start date. So next here, I just set up a transition so that the chart, the position of the dots change over time based on the starting, and varies from the start date to the end date. Then here, I'm just updating the position of the dots and the position of the labels based on the accessor functions and the scaling functions that I declared on the previous slide. Then here, this just varies the date between the start date and end date, and it calls the display date function, and the display date function just the average rows and the average rows process and the count based on the particular time. And I use this interpolate function. It's a helper function that just interpolates data if we have any missing data for a particular time. And yeah, so that's pretty much how that works.
All right. Yep. Thanks, Thomas. All right. Just super quick. Everything I ever learned, I learned in Dreamforce 2014. A couple best practices to keep in mind. You saw a great Apex integration that Heiko built with New Relic. It's great for smaller volumes. For larger volumes, we definitely recommend using the API. It's fast, it's efficient. You can even take a look at the log file length to understand sizes. Parsing base 64 blobs is fun. We all know that, right? Definitely try downloading the files first and pre-aggregating data. It really does help out. Finally, this is something that you can try out. If you have a DE org, a developer edition org, it's already there. If you don't, you can go to developer.salesforce.com, sign up for an org, and you'll see this event log file object there. And then, of course, I'll leave this slide up as we take a couple questions, but this was all the demos, all the libraries, all of the information that you saw today is generally available out there. It's open source. Please feel free to take advantage of them. So we have about 3 minutes. We would love to take a couple questions. We have a mic that's in the center if anyone would like to head up there. Anyone? Bueller? Please.
Actually, I have a question about user monitoring as to what the user is doing in the Salesforce instance. So we have like 1,000+ users in our org, and we are not able to kind of tell what the users are doing in the system. Mm-hmm. Is there any way we can use these to get that information?
Yeah, absolutely. So the question is, can you recreate what users are doing, what their behaviors are, what their trends are?
Right, yeah.
Right, so those files that I showed you that I downloaded into my local directory, whether it's Apex or API, whether it's content transfer and the ability to see what chatter files they're downloading, they're previewing, whether it's their login and logout, when you're installing and upgrading packages, and most importantly, every single click you'll see in the URI file as a URI at the top of the screen. Oh. So we do know when people export, we do know when they click on a tab or a page.
Right, okay. So within a page, now there are certain sections, right, related lists. Can we track that as well? No.
If it results in a URI change, yes. Okay. But if you're looking for more like a heat map kind of functionality where we're giving you the granularity of they hovered over this particular part of the page, that is not something we capture currently.
Right, okay. But this is useful. Thanks.
Thank you.
So the data in the setup audit trail,
yes.
Can we use event log files to get that data?
So
setup audit trail? Like
question.
Modification to an Apex trigger, modification to some code, modification to, let's say, a new field is created, stuff like that.
Absolutely. So let me handle the first one. Setup audit trail was designed much like field history tracking to show change in state. Permission set change from A to B. That doesn't go away, it still stays the same, it's still not API exposed. This is slightly different. I can get information about setup, but it's going to be what did people click. For instance, setup audit trail doesn't tell you whether or not someone used the search functionality. It doesn't tell you whether or not someone looked at a workflow rule. It doesn't tell you whether or not someone looked at a log itself. So they're complementary in that way. And then the second question is, we don't actually store data, as you can tell in these logs. It's about the event itself, right? And as a result, we won't tell you what changed about an Apex class, what changed in a Visualforce page. We will just simply tell you whether or not they went to debug console to be able to actually look at it.
Okay. So the stuff that's in the view setup audit trail, that has not been API exposed yet?
It has not been API exposed yet, no.
Okay. All right.
Thank you.
We have a use case for FDA auditing where we would like to correlate this kind of information to the field tracking history. Well,
yes.
You look at the field tracking history, and you may have 1, 2, 3, 4 changes that took place, and
yep.
maybe to different records
yep.
as a result of a single button click. And any pointers there?
Absolutely. So that's really commingling of different data sources to do a
Yes.
forensic investigation.
Yes.
I want to, for instance, recreate what someone saw when they saw a report. And so I want to not only go and take a look at that report URI and determine what columns were in that report, I want to look at the state of data. And to do that, I need to pull down information about the state of those fields from the record. You would have to pull all that into a single data store. New Relic Insights would be a good example of one way you could do that. Salesforce Analytics Wave also a way to do that. It's essentially an analysis tool for being able to pull all that together. But it is a lot of data. To give you some idea, we house somewhere in the neighborhood of, I think, 100 billion rows of field history tracking since its inception 9 years ago. So the one thing I would warn you about is it's a lot of data, and you have to be ready to manage that data. So,
Thank you.
But it's all API exposed. That's the good news. Other questions?
So going back to the salmon, when will we ever see this on a live org?
I'm sorry, say that again?
Going back to the salmon, when will we see this in a live org?
So this will be available in production orgs starting in mid-November.
Mid-November, okay.
Absolutely.
Will it be available in sandboxes as well?
Yes. So when you refresh the sandbox, the provision bit will transfer over.
Will there be a notice, or will it just magically appear?
Magically appear.
Okay. Should I write you to let me know when that date is?
Absolutely. Come up afterwards and take my card, and we can absolutely follow up after Dreamforce.
Thanks.
You got it.
Just in terms of the refresh on this data, so you can make the API calls out like that, and you're saying it'll store, in this case, 1 day of data, except for 30 extension case. So is this done on a time interval? Is this done like every 5 a.m., let's dump the data, or is it just real time?
So every night we ship the logs off. We map reduce over them at 3 a.m. in the morning based on the server time. So that typically means the actual files are available by the time you're getting in for your first cup of coffee or tea, depending.
Okay. All right, thank you.
This is a paid version for production, right?
Sorry, say that again?
Is this a paid feature in production?
It is going to be a paid add-on feature in production, yes. It's free in Developer Edition. All right. Thank you very much for spending your time with us this afternoon. We really appreciate it. Have a great rest of Dreamforce.